Hi, we are going to continue the last video on the topic of compressor. In the previous videos, I have shown you the introduction, centrifugal flow compressor, axial flow compressor, operating conditions, and airflow control. So in this particular video, I will discuss about the materials as well as the balancing of compressors. In terms of the materials, materials are normally chosen to achieve the most cost-effective design. Obviously, the engine manufacturer, when they want to decide what are the material to be used, they will look at the dollar sign or the ringgit sign. In practice for aero engine design, this need is usually best satisfied by the lightest design that is technologically allows for the given loads and temperature prevailing. We start with the casing. What materials are suitable to be used in casing? Is it going to be just one type of materials or a combination of materials? For casing designs, the need is for a light but rigid construction, enabling blade tip clearances to be accurately maintained, ensuring the highest possible efficiency. These needs are achieved by using aluminium. We know aluminium is light at the front of the compression system, followed by alloy steel. So you have aluminium in the front of the casing side, and then it is followed by alloy steel as the compression temperature increases. Whilst for the final stages at the rear side of the casing of the compression system, where normally temperature requirements possibly exceed the capability of any known best steel, nickel-based alloy materials may be required. The use of titanium in preference to aluminium and steel is now more common, particularly in military engines. What about the stator vanes? Normally, stator vanes are being produced from steel or nickel-based alloy. A prime requirement for stator vanes are being a high fatigue strength when notched by ingestion damage. Okay, sometimes foreign object goes into the compressor, it will damage the stator vanes. Aluminum alloy use has declined due to its inferior ability to withstand damage. In the early design of engine, normally they use aluminum alloy, but not anymore. Titanium is unsuitable for the smaller stator vanes because of high pressures and temperatures encounters. Now, for the roto. If we look at the roto, it consists of roto disc, drum, as well as the blades. And we know that centrifugal force dominate, and the requirement is for metal with highest ratio to strength density, right? I repeat here, highest ratio to strength density. So this results in the lightest possible roto assembly, which in turn reduces the forces on the engine structure, enabling a further reduction in weight to be obtained. So what are the materials that is suitable? So for this reason, we use titanium. Even with its high initial cost, it is preferred material and has replaced the steel alloys that were favored in early designs. As higher temperature titanium alloy are developed and produced, they are progressively displaced the nickel alloys for the discs and blades at the rear of the system. Finally, it is about balancing. and we want to look what and how the balancing look like for a compressor. So at this stage, balancing of a compressor rotor or impeller is an extremely important operation in its manufacture. Okay, in view of the high rotational speeds and the mass of materials, any unbalance would affect the rotating assembly bearings and engine operation. So we are not going to go into the detail of how the balancing is being made. You may look into other texts or materials that explain in detail how balancing of compressor rotor and impeller being done. Is it the same like the automotive car tire balance, or it has a unique process in it?